Failing a subject is bad. Failing a whole subject is even worse. Pero ang mas mahirap dito ay kapag pinalayas ka ng nanay o tatay mo. Magdasal ka na lang na marunong ka maghugas ng pinggan o magwalis. Kaya nandito ako para kayo ay tulungan. Fret not, for I am here to help. Chemistry. A concept and subject that can be considered as the bane of every student's existence. Yet, as much as hard as it is still one of the most important subjects to ever exist, alongside mathematics per se. It is one of the hardest subjects to take in high school, and even all the way up into college. But thanks to our wonderful teachers and professors, it becomes much more endurable. And also, thanks to our Indian and American brethren on the internet, it became even more bearable to learn.
E Yen J I Yen E R Ingi Ni.
Are you one of those people who are having difficulties learning? Well, you came to the right place. Welcome to my lesson on how to balance redox equations by half reaction method in acidic and basic solutions. Hello, my name is Isaac and welcome to my tutorial on how to balance redox equations and get their acidic and basic solutions. What you want to know first is that there are rules in getting oxidation numbers. The oxidation numbers are then important in getting, in balancing redox equations. So it's very much important to know and be familiar with these rules right here. But don't worry, I will discuss the rules one by one, and I hope that you'll get it by the end of the lesson. So, rule number one is basically element by itself equals 0. If an element is by itself, it will always be equals to 0. So, that means that, for example, you see a lone carbon inside a equation. For example, if you add carbon here, that means this carbon right here is equals to 0 because it's alone. Another example, if you see a lone hydrogen, then it's 0 as well. If you see a lone aluminum, it's 0 as well. It's honestly that simple. So let us move on to rule number 2, rule number 3, and rule number 4. These rules I can explain with a periodic table. So let's move to a periodic table right here. So this is group 1, this is group 2. The rule states that if it belongs in group 1, the charge will always be positive 1. So if it's in this column right here, the charge is positive 1. Remember that? And if it's in this column right here, the charge is positive 2. So remember that this is group 1 and this is group 2. The next one is halogens. A halogen is, if you see a halogen, the oxidation number of it will always equal to -1 unless it's paired with an oxygen. So halogens can be found on the periodic table at group 7A. This column right here are all halogens. This column right here are all halogens. So these are equal to -1 unless if it's paired with an oxygen, that -1 becomes positive. Let us move on to another rule. Monatomic ions. Monatomic ions are basically elements with an ion charge to them. So for example is this Cl minus, or Cl subscript, Cl superscript minus. Notice that there's a superscript. Same thing here with the manganese. Yeah, this is a manganese. Same here with the manganese. There's a 2+ superscript. So as I said earlier, an element by itself is equals to 0. Notice that the rule number 1 doesn't apply to this because there is a charge to it. So the rule states that if it's a monatomic ion, the oxidation number will be equals to the ion charge. So meaning to say, chlorine here, for example, will equal to -1 because it contains the negative in the superscript. And in this example right here, manganese will equal to positive 2 because, like I said, there is a positive 2 charge in the manganese. So positive 2. These are the oxidation numbers for our monatomic ions. So let's move on to hydrogen. Hydrogen, this is very simple. Hydrogen, if it's with a non-metal, it will equal to positive 1. If it's with a metal, it's a negative 1. So it will always be 1. The only hard part of determining the oxidation number of hydrogen is determining whether the element that it's paired with is non-metal. But there's an easy way to determine that. Let's go back to our periodic table. So starting from carbon all the way up to radon, all the way up to helium and hydrogen, these are all non-metals. That part of the periodic table are all non-metals. Remember that. Because, like I said, like the rule states, if a hydrogen is paired with a non-metal, with those ones that I box, it becomes positive. If not, if it's a metal, negative 1. Next rule, oxygen. Oxygen will always equal to negative 2, unless. Oh yeah, by the way, the rule number 1 applies to all of these, by the way. So if you see a lone hydrogen, that's 0. If you see a lone oxygen, that's also 0. I'm just saying that these are how do you call it? These are compounds or paired with other elements. For example, this O should what's a good example? Let's just put a random element. Let's say aluminum. It's paired with an aluminum. These O will always have a value of negative 2 since it's with another element. But again, if it's alone, it's a 0. Remember, that's also important. Remember that. So, if it's oxygen, will always equal to negative 2 unless it's in peroxide, which is this equation right here. If it's in peroxide, the value of this oxygen right here is negative 1. Okay? Then the last rule is that F will always equal to negative 1. F here stands for fluorine. F is equals to negative 1. Always. That's a constant. Unless it's alone, obviously. Like I said, if F is alone by itself, that becomes 0. Common sense. This is rule 1. It can be very confusing, but I recommend you do practice problems and determining oxidation numbers of elements. It will actually help you a lot. The next one, okay. The next thing we should do is that, by the way, this is our example problem right here. This is, this is our example problem of a unbalanced redox equation. This is our example and the problem that we're gonna try and solve. So the first step, so now let us move on to like actually getting the acidic and basic solution. So the first step in determining and balancing redox equations is you want to get the oxidation numbers for the elements in the equation. So let's start with the very left. Manganese and oxygen, these are both together. So like I said, rule is negative 2. Oxygen is negative 2. And as you can see here, there's a subscript of 2 here. That means that this subscript and this superscript will multiply by each other, and then you will get -4. Now don't be confused. -4 isn't our oxidation number. The oxidation number for oxygen is -2. Remember that. So you have -4. How will we use -4 in determining manganese? Sum of for a neutral compound, the sum will always be equal to 0. This is a neutral compound, and we have to make this -4 into 0. How do we do that? Simple. We add +4 to manganese. So +4 and -4 will cancel each other out, and you'll get 0. So the manganese, the oxidation number for manganese is then therefore +4. Okay. Quick side note: how do you tell a neutral compound from a polyatomic ion? A neutral compound will not have a superscript, and a polyatomic ion will always have a superscript like these. These are the superscripts that I'm saying. A neutral compound won't have those things. So let us continue. So we figure out which is the which ones are neutral compounds and which ones are polyatomic. Let's move on to chlorine with a superscript of negative. The rule is with monatomic ions is that the ion charge is the oxidation number. So we've already determined that chlorine here has a charge of negative, meaning to say that the oxidation number for this chlorine right here is -1. Same thing here with the manganese, since it's a monatomic ion. 2+ or +2. Therefore, that +2 right there is our oxidation number. So, last one, Cl2. This is rule number 1. It's an element by itself. Do not get fooled by the subscript here, because that doesn't mean it's a monoatomic ion. This is still an element by itself. Remember that. A superscript and a subscript are different from each other. Remember that. So meaning to say, this chlorine right here is 0. So, we now have our oxidation numbers. +4, -2, -1, +2, and 0. The next step is finding which element is being oxidized and which element is being reduced in the equation. So let us move slides. Yeah, here we go. Hold on a sec. There we go. Yeah, there we go. So which element is being reduced and which element is being oxidized? So as you can see here, I've already listed down the oxidized numbers that we solved earlier. See, +4, -2, -1, +2, and 0. So what we have to do now is determine whether which element, like I said, is reduced and which element is being oxidized. Very easy. So when we talk about an element that is being oxidized, is basically when an element is then when an element loses electrons, while reduced is element that is being electrons are being added to an element that is reduced. So reduced, electrons are being added. Oxidized, electrons are being reduced. Okay, I think it's easier to show it with an example here. So example, our manganese, oops, that's not something. Manganese, positive 4, it became positive 2. So meaning to say, elements, positive 4 and positive 2. Yung positive 4, positive 4 became positive 2. So, meaning to say that electrons are being added so that it becomes positive 2. Therefore, manganese is reduced. For simplicity's sake, I'm just gonna put R for reduced. Next, chlorine. Our chlorine right here is -1, and then it became 0. Meaning to say that electrons are being taken out of chlorine. So meaning to say this is oxidized because -1 is lower than 0. 0 is higher than -1. So -1 becomes 0. So meaning to say it loses electrons. So meaning to say it's oxidized. So now we have determined whether which one is reduced and oxidized. We just have to write it down in like half reactions. So R for reduced is MnO2 and Mn2 plus. And O is for oxidized, Cl minus Cl2. And that is our reduced and oxidized half reactions. These are called half reactions, by the way. So let's move on. There we go. Let's move on. Now, since we figured out whether which ones are since we have figured out which ones are being oxidized and being reduced, and I've split them up, we then now have to balance out these half reactions. Let's start with this first. They're reduced. So, wait, did I write? I'm just gonna check real quick. Reduce MnO2 and Cl minus oxidized. Okay. Okay, I was right. So let's balance out our reduced half reaction first. So let's write it down first. MnO2 minus MnO2 arrow, then Mn2 plus. Split it in half. Then on this side, write down the elements that belong on this side. Manganese and oxygen. And on this side, we only have manganese. So, how many manganese do we have? Do not mistake this for oxidation number. What I'm asking here is, how many manganese, how many oxygens do we have? So, we only have 1 manganese here, and 2 oxygens on this side. And on this side, we only have 1 manganese. So, notice that on this side, there is a oxygen element. There's a oxygen element. And on this side, there is none. So, meaning to say that on this side, we have to add oxygen. So, how do we add oxygen? We add water, or H2O, to balance it out. So, we only need 2 oxygen. So meaning to say we only need 2 H2Os. 2. But wait, introducing water now then adds hydrogen. Now since we have hydrogen now, 2 times 2 is equals to 4. We have 4 hydrogen, but on this side we don't have any hydrogen whatsoever. So meaning to say that we have to add hydrogen on this side now. How do we add hydrogen? To add the hydrogen on this side, the only thing that we have to do is add 4H. 4H plus. This is a superscript, by the way. 4H plus. And now we have 4 hydrogens. Now it balances out. We have manganese. We have manganese, we have oxygen, and we have hydrogen. The last part is balancing out electrons. Now, on this side, we only have plus 4 electrons. And on this side, we only have plus 2 electrons. It's this. So, as you can see, these both numbers are not balanced. And to balance it out, what we usually have to do is to add electrons to the side which has the higher number. So in this case, positive 4 is higher than positive 2. So we have to add electrons over on this side. So what we have to add is, sorry it doesn't fit, but what we have to add is only 2e minus. We have to add it here on the left of 4H plus. I'm sorry, I didn't manage to fit it. So since we added an additional 2 electrons, becomes minus 2 equals 2. So now our electrons are now balanced. Now we can write it down here in the bottom as 2e minus plus 4h 4h plus MnO2. We just have to basically write it down Mn2 plus 2H2O. So we have balanced out our reduced. Let us move on into our oxidized. So let's do it here. Cl minus Cl2. Same thing. Put all the elements that is present. So as you can see here, we have 1 chlorine, and on this side we have 2 chlorine. See, there's a subscript of 2 here, so meaning to say there's 2 chlorine. So it's not balanced, right? Because this is 2, this is 1. That is not balanced, so we have to balance it out. So what we have to do is add 2 here on this side and multiply the number 1 with 2, and then we get 2. Now our chlorine is now balanced. 2 chlorine, 2 chlorine. Now on this, remember on our manganese, on our reduce, when we were doing the reduced side, that we had to add H2O, we had to add 4H. On this side, we don't. Why? Because there is no oxygen, there is no hydrogen on this side. So we don't have to do any of that. We can jump straight into our into balancing electrons. So on this side, we have negative 2 electrons. On this side, we have negative 2 electrons, and on this side, we have 0. Since we have 0 on this side, we then have to add electrons on this side then. 2e minus. So then we just do negative 2 equals negative 2, and then we have it balanced now. So we just have to write it down. 2Cl minus 2Cl minus, and then Cl2 plus 2e minus. And that's a negative sign. So we have 2Cl plus Cl2 plus 2e minus, and then for our oxidized and our reduce, 2e minus plus 4h plus MnO2, Mn2 plus 2h2O. So remember these numbers right here, because that will be important for our next step, which is basically canceling out our electrons on both sides. So let's move on to that. There we go. So these are the numbers that we got last time. What we do here now, sorry, I'm getting my brain is not working. So what we do here now is basically cancel out the electrons so that yeah, basically just cancel out the electrons. So here we have 2e minus, same on both sides, meaning to say it cancels out. And then we can rewrite the whole equation now by combining these parts, the left sides, into one. As you can now combining both the left sides into one as 2Cl minus 4H plus MnO2, and then Cl2 plus Mn2 plus 2H2O. And that, ladies and gentlemen, is our acidic solution. This is our final answer for acidic solution. There is a way to check if you're right, by the way. It's basically just balance it, figure out if it's balanced or not. For example, so we have Cl, hydrogen, manganese and oxygen, Cl, hydrogen, manganese, oxygen. So we have two chlorine. So we have two chlorines here, 4 hydrogen, 1 manganese, 2 oxygen. On this side we have 2 Cls here. We have 4 hydrogen here. We have 1 manganese here, and we have 2 oxygens. As you can see, both sides are balanced, meaning to say that our acidic solution is right. Now, let us move on. So now, since we have found out our acidic solution, we are now going to try and find out the basic solution for this equation. The basic solution is basically the same process in the same process. You go through all the same process until you find the acidic solution. Then you add an additional step just so that you can find the basic solution. It's very simple and very easy to do. So let's just do that. So let's do that. So this is the acidic solution. Remember, that's the acidic solution right there. So what we have to do to get the basic solution is basically eliminate 4H+. We have to eliminate 4H+. And how do we do that? To eliminate 4H+, what we have to do is add OH negative. So since we have 4H+, what we have to add is then 4OH negative to that side. So and then these two then becomes 4H2O. It's vital that these become water. These become 4H2O, but since we are eliminating 4H+, we need to eliminate every 4H+, every H+ in the acidic solution to get the basic solution. So on this side, since we added 4OH, we also add another 4OH since we added 4OH on the other side, like I said. And notice that we have H2O on this side and H2O on this side now. They are both the same element. They are both the same compound, meaning to say that we can how do you say it? How do you phrase it? Combine it together, I guess. Or at least what you do is basically cancel out this one and then minus 2H2O. Minus 2H2O equals 2H2O on this side. But this cancels out. So we then have to rewrite our final answer now as 2Cl minus plus 2H2O, 2H2O plus MnO2, O2. On the other side, Cl2 plus Mn2 plus 4OH negative. And then, ladies and gentlemen, we have our basic solution. There's also a checking for basic solution, by the way. So Cl, we have Cl, hydrogen. I'm just gonna put it here since we have no more space. Mn, on the other side, Cl, Mn, OH. Oh wait, whoops. Cl, hydrogen, oxygen, manganese. Cl on this side, 2, because you have 2 here. Hydrogen on this side, 4. So you have 4 here. Oxygen on this side, here we have 2. And then on the other side, we have another 2. So plus 2, 4. We have 4 in total. And we only have 1 manganese. On this side, we have, how many Cl do we have? 2. So you have 2 here. And then how many hydrogen do we have? Hydrogen, 4. So 4. And then on this side, on oxygen on this side, we have oxygen, then 4. Therefore, we also have 4. And then manganese, we only have 2. Oh no, 1. Right? Yeah. Ah, yeah. This is a superscript. I almost got confused there. So we only have 1. Okay, good. So we have 2, 4, 4, 1. Balance is out. Balanced out. And now we have our basic solution and our acidic solution. Both have checkings, and yeah. You should always do the checking if you have additional time, since it honestly is a lifesaver, and it tells you whether if you did it wrong. Yeah, always do the checking, guys. So that's about it. Thank you for watching, and if you have additional questions, I will gladly answer it in the comments section, or you can private message me if you want. So yeah, and that's about it. See ya.